OneCircuit Mailbag, coming to you live from downtown Tasmania. OneCircuit, when you've got nothing better to do, give us a try. Bit of rattle in this one. Let's see why. Because there's a lot of M4, I want to say, M3 10mm bolts and M3 12mm bolts, and these little guys, which are really handy. We've seen these before for heating up, putting into like 3D printed enclosures and then screwing on the top. I'll show you what I'm working on at the moment. Okay, so this one here, so you can see in the 3D print I've actually made a corner here on each of these, which doesn't go all the way down. It's just a little bit here, and you can see that the well, hopefully you can see that it's just enough for these things to go in. And then this lid, when it goes on the top, the screws, these are M4s, it screws down the lid quite tightly. And yeah, it's just a little nifty way, which I think I saw for the first time with Pile of Stuff, but I've used it a few times since, and it's a pretty handy mechanism for connecting two things if you've 3D printed them. So you just put your soldering on tip in this, push it into the plastic that you've created, and then the screws just screw straight in. So yeah, these would be M3s too, then I'm guessing. Yep, M3, and so I've got some M4 versions of that, so the M3s are there now to just add to that. And what is this project? It's a toy for a very special boy, my grandson actually, and so yeah, I'll make a link to one of these that I've made before, and this one is the latest incarnation. Right, and this one is, ooh, wow, one of something with a huge heatsink on it. Why such a big heatsink? It says BT2, and we have a B-, a B+, an M-, and an M+. On this side, we've got, I can't even, VCC and ground, and then a whole heap of squiggly things. Oh, okay, we can read it better on this side. Let's get in there a bit closer. So VCC, ground, and then REN, LEN, what is it, RIS? LIS. Yeah, I have no idea what this is. It's got a chip, well, a few chips on it actually. Let's have a look and see what this says. So it says 74HC244D, and these guys, they look like, could this be audio? I'll have a look at the listing and find out just what this is. Yeah, so high-powered motor driver apparently, which has been given a little bit of a nudge in transport. These are not looking that well. I'm sure we'll be able to straighten them out and get them to fly right. But yes, I have played around a little bit with motor drivers. I think the L298, I did a little video on that recently, relatively recently. But, oh, okay, so that's not a good thing. But this one is supposed to be for quite big motors. So it'd be interesting to see how it goes with some of the motors I've got. So recently I went to sort of like a recycling centre, I guess you could say. Are they okay? Gosh, they've been given a decent whack. And anyway, I did get some motors. Do I have those handy? Oh yeah. Right. This guy, zoom out. Not too much zooming available. It's a pretty big guy, yeah. So I just thought, okay, to drive that, I think I've got another one as well. Let's see what I can find here. Oh yes, I've got a couple of them. So these are just available at the local recycling centre. Big motors. And so I thought, well, yeah, maybe you might need something that's capable of driving that. So I'll put this to good use in a future video, hooking up to these monsters and see how it goes driving it. And this one contains ICs, and they are CD. Can we see that? CA3046. CA3046. I wonder what they are. So the CA3046 is a transistor array, an NPN transistor array. So again, I think I'll wait for a future video to put this to some use, put it on a breadboard and see if we can hook it up. I guess it's similar to the ULN2083 in a way. I'm not really sure, but yeah, we'll put it to good use at some future point. Transistor array. And this guy contains LEDs. Yeah, but what sort of LEDs? I have no idea. Let's take one out and we will solder it up and see what color it is. All right, that's some very crude soldering up, but the end result is, wow. Yeah, interesting color. I'm not sure if we can see that. Let's try this. Oh yeah, that's nice. So it's sort of like a yellowy green. I don't think I've ever seen that color LED before. That's probably why I got them, because they're a little unusual. Yeah, nice one. Nice little LEDs. I think they are, what are they? 1206, I assume. Certainly not 805s, but yeah, beautiful color. Green slash yellow. Nice one. A bit of a chunky one. Let's see what's inside. Wrapping paper. Well, wrapping plastic. 8 by 8, 8 by 3, 100 pieces. And no apparent way of getting in. Let's try here. There we go. Wow. It just keeps going. It's a babushka. Try that. Still going. Aha. Yes. And it appears magnets. So many magnets. 100 magnets. 8 by 3 would probably refer to the diameter and then probably the thickness. Should we test that? I'll see if I can find my little micro measuring device. Alrighty, so this could be interesting because it's going to want to probably leap up and grab this. But we've got, yep, we've got, come on, oh, it's fighting me. Well, 805 looks pretty good, and the other one was the other one was the width. Come on. Well, there's no doubt that they're magnets and strong as well. 2.92's pretty good. Yeah. So yeah, nice little magnets, which I use for all sorts of things, but more particularly just for sticking things on fridges and that sort of carry on. Who doesn't love a good magnet? And let's just nip the corner of this one. and see what we've got. A couple of programmers. Well, not really, no. What we've got is a couple of clamps, programming clamps, that you can use to program devices in situ. So sometimes I need to make changes. I discover a much better algorithm for doing something. But the problem is that the little, usually a tiny 13 is already in situ and cannot be reached. So this allows you to do so. So you've got little teeth at the end, which we put over the top of the device, and then we reprogram them. So yeah, very handy to reprogram devices that, oh, these teeth are a little bit wobbly. Look at that. It's had a bit of suffering in transit. But the idea is, yes, you've got a microcontroller that you'd like to reprogram, and you're not going to desolder it, so you try and do it while it's actually sitting on the board. Nice one. What a ridiculous setup. With most things are hidden under here too, which is a bit of a shame, but let me take you through it. So I've got a USB ASP out that way, and that's going to my normal ATiny13 programmer. But the ATiny13, which is buried under here, well, I'm simulating that it's on a board somewhere, so I can't get to it. So instead, I've gone from my normal programming setup, which is MISO, MISO, clock, and reset, over to this board here. And then coming out of that is the ribbon, which goes to those that claw, which is actually stuck onto the top of the chip. So I'll pull all this off to show you, but it's a bit of a delicate thing to get this thing clamped onto the ATiny13. So I'll just leave it there for the moment. We'll change the timing from blinking on 1 second and off 1 second on the LED there to let's say 100 milliseconds on and off, and that should be quite noticeable. So let's upload it, and there you can see that works. So let's disassemble it just to show you what's actually happening. So the blinking will go off, don't panic. But there's the claw there, so that sort of actually got clamped on. There's my ATiny13, and common ground over here, but I'll just remove that, and we'll keep going back to this one here. So I'll pull this one off. So that's the ribbon attached to the adapter board. That's a DIP 8, and then that was sitting on this breadboard, and then you can see all the wires going back: VCC, clock, MISO, MISO, reset, and ground, and that goes back to, let's pull that all off, to the programmer itself. So just to show you again how it would normally work if I had the chip not available, so not on a PCB, then I would simply program it like this. So let's get that blinking back. So this is sort of disassembling back to front, and if I just go 1 second again for on and off, and then upload that, this is the normal process. Yeah, so that's pretty straightforward. But if it was somewhere else, then what I can use is this adapter, ribbon, and clamp, and I can actually program it wherever it is. Very handy piece of kit. Right, and the simpler version here, without all the confusing wires, is the DIP 8 adapter plugged straight into the programming adapter. So remember that the USB ASP is out to the side here, and then we have the ribbon coming to the clamp, which is on top of the ATiny13. So let's slow that timing down just to show that this rig works as well. And there it is. So yes, if you don't want to desolder the ATiny13, then you can just clamp on and reprogram it in situ. Whoa, local delivery. This one seems a bit heavier, so we'll go with this guy first. And these have come from Core Electronics, I think, in Sydney. Oh, boxes aren't my favourite. Let's see if I try this guy. What happens? Thinking about it. Yep, and there's paperwork, so we'll ignore that. It's a lot of air in here. Okay. And Raspberry Pi Pico with a pinout. Nice. And also some guides, some how-tos, so that's pretty pleasant as well. So yeah, the story is here that when the Picos came out, I think they were around the $4 mark, and I couldn't really see much of a use for them, but I was fascinated by this sort of grey area between microcontroller and microprocessor. So I thought, well, I'll get a couple of these and see how it goes. Now that's interesting. I thought I'd ordered 5. Let me just check the order. And it says 4. I'll have to check my paperwork at the other end. Okay, so I thought I was getting 5, but I got 4. And I think the last order I got, which was quite a while ago, oh, these have seen some action. It was quite a while ago, and of the 5, I think I've only got 2 left. So basically what I was doing was giving them away, saying to people, hey, look at this, it's really interesting. There's this this new, I don't know what you would call it. It's almost like a replacement Nano, but with a bit more power in some areas and a bit less in others. I was also looking at Great Scott and his video from, well, just recently really, and he took a second look basically at this Pico, and he wasn't too impressed when he first saw it, from what I understand, but then, you know, looking at it a second time, he said, yeah, that's pretty cool. And it's interesting because it's driven by this RP. Let's see if we can, actually I'll zoom in and we'll have a better look at it. So at its heart, this is the RP2040 or 2040, I've seen it referred to. There's lots of other bits and pieces on here. This is sort of like well, it's not quite a minimalist board, but the sorts of things that you need to have this machine talk to the outside, etc., etc. So I'll put that down here, and I might also list a comparative list here of, for instance, the Nano versus this. The price points are pretty similar at the moment. I mean, they always pretty much have been. So Arduino Nano or Raspberry Pico, pretty much the same. And there's a lot of variants now that are coming out. There's some commercial ones, and there are also some open source ones where you can use this chip, because this chip is still, amazingly, despite what's happening at the moment, is still quite available. So yes, I'm hoping to use these to replenish the ones that I've given away. I won't be giving these ones away. I'll be using them to maybe fill in the gap between a full microprocessor that you might find on a Raspberry Pi. I've got some 3Bs around the place. I've also got some Orange Pis, PC Pluses, so that's like the full-on operating system, etc., etc. And then there's those sorts of projects that require minimalist processing, such as just monitoring a system. And this sort of, I guess it sort of fills the middle bit in. And you can program it, I'm pretty sure, in both C and MicroPython, so that's pretty cool as well. What I might do is actually boot one of these guys up and, well, of course, let's get it blinking. So, unfortunately, the pins aren't marked on the top, they're marked on the bottom, but this is GPIO20, and that's ground. And although you can program this in a number of different ways, I have downloaded the Arduino core for this board. So, yeah, just basically working with what I'm comfortable with, although, you know, Python would work just as fine, if not better, probably. But that's what I've done. So theoretically, I can get this thing blinking. I think I've got it at 10 hertz. Let's try and upload. So compiling is okay, uploading is okay. Oh, and blinking is okay. Yeah, so this will be a bit of fun to explore, I think, this whole thing. Maybe it's time I got into MicroPython. I mean, there are some other beasts that you can program with MicroPython. I think some versions even of the ESP32, but I've yet to explore that. But a blinking LED, you can't go past that, so yeah, I say this one's working. Nice. That is the mailbag for the week, and we'll catch you next time. See ya.